So here is a question. Here is a question that we have the spherical body with the cavity, and we have to find the gravitational force for the particle that is placed inside this cavity. So the particle is anywhere like this and this. So we choose here the particle would be here, that is would be P1 point. So C1 is the center of this big sphere and C2 is the center of this small sphere. This small sphere is actually a cavity. Cavity means the body. Cavity means, let I explain you, a body whose this part is empty and the other part is filled. It means that the part outside this circle, outside this sphere, is filled with material, but inside this cavity is not filled. That is cavity. Here let we distance between the C1 and C2 centers of the big sphere and small sphere respectively is the L, and P1 is the point where the particle mass is present. So for the particle mass, the force will be G mx upon Re cube. It is for the uniform sphere where is no cavity, as we know that the force would be a gmx upon Re cube. And if we write in the form of density, then it would be a G 4 by 3 pi Re cube rho x upon Re cube. Here we write the m into a 4 by 3 pi Re cube. So the force in the form of density, it would be a G is equal to 4 by 3 pi rho x. Now, so as I said that the particle is anywhere. So as we know, the particle is here, anywhere would be. So how to do this question? There are the two ways. There are the two steps doing this question. First, we find the gravitational force for this big sphere, and then we find the gravitational for the identical size with the same density that would fixed in this part. That would be a C2P. That would be a this sphere with the center C2. This part is identical with this part. If it means we put this part in this cavity, and this makes a whole uniform sphere. Let do this question. So now we write the FC1 vector for force C1 vector for this sphere. That would be a minus 4 by 3 G pi rho C1P vector. Here X is the C1P vector. We write in the sense of vector. So we write the X is C1P because this is C1, because this radius is C1P. And why this minus here? Because as we know that the force is that the force affecting inward and the radius is outward. So because of the opposite sense, there would be minus place here. Same as here for FC2 vector for this sphere, we write minus 4 by 3 G pi rho C2P vector. C2P is here because the radius is C2P, and minus because force, as we know that the gravitational intensity for this sphere is affecting inside. Is affecting inside and the vector is outside. So we write the minus vector because minus. Okay. Now for finding for the force for this cavity, we have to find F net. For finding F net, we have to subtract FC2 from FC1. Then it would be a minus 4 by 3 G pi rho C1P vector minus plus 4 by 3 G pi rho C2P vector. Now F net would be a 4 by 3 G pi rho C2P vector minus C1P vector from the vector addition. Yeah, this is a triangle. It follows a vector triangle addition. That would be a C1 C2 plus C2P is equal to C1P. Okay. Now here C2P minus C1P. Now from this rule, C1P minus C2P is equal to C1 C2, and here it is right C2P minus C1P. So we write minus C1 C2 because it is opposite of C1P minus C2P. So here we write minus C1P. So minus C1 C2, and minus C1 C2 is actually L. We have supposed that the distance between this center is L. So we write here L. and minus is here. So F net would be a minus 4 by 3 G pi rho L. That's it. Now one thing you have to see that the force is affecting only that this part is constant, this part is constant, this part is constant, and this is L. This part is constant with the minus, and this part is L. L is the distance between the C1 and C2. It means that the force that affecting for the particle that is placed inside the cavity is only depend on the radius. It's only depend the distance between the C1 and C2. So particle is anywhere like here, like here, like here. The F net for the particle inside the cavity is only depends on the distance between the C1 and C2. So here we write minus here we write minus C1L. So that's it. Thank you. Bye.